Arseni, Assistant Professor in School of Computer and System Sciences. Our today's topic is number system. As we have discussed in the last class, binary logic gates, or we can say logic gates. In today's session, we will discuss about the number system and how these are important in the digital electronics. To understand the digital electronics, the importance of number system is so much. Okay, let's start. '52. What does it represent? 52 is a number in which the symbol 5 and 2 in decimal number. Decimal number means there are 10 symbols. 10 symbols start from 0 to 9. And 52 is one of the combination of 5 and 2. And now you can see it is 101100.101. It is in binary number. It may be in octal number. It may be in decimal number. What is the meaning of the radix? Radix or the base value is the value or the system or the number system in which we are talking about the number or the sequence. Number system. In the number system, the base is very important. Till now, we know about only decimal number system. Suppose I want to ask to anyone, please give me 100 rupees or 2000 rupees or 5200 rupees. Now we are considering these numbers by default in decimal number system, because in journal life or in our journal life we are using only decimal number. Okay, there are a lot of number systems are there. The importance of the number or the application of various numbers in various fields, like the computer understand the binary numbers like 0, 1, 1, 0, or the combination of binary numbers. Why it is called binary, we will discuss in the next few slides. Okay, there are some famous number systems. First of all, binary number system. Second is octal number system, and decimal as we know, and the hexadecimal number system. Yes, decimal number system, as we know, it is very useful in our daily life uses. Okay, binary number system, computer systems are using the binary number system. Hexadecimal number system and used in microprocessor and a lot of microcontroller systems. It is the table which represent the decimal, binary, octal and hexadecimal numbers. In the decimal 0, 1, 2, 3, 4, 5, 6, 7. In the column 1 we can say there are 8 symbols. These are symbols. 0, 1, 2, 3, 4, 5, 6, 7, 8. The binary representation of these symbols is 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. In the octal, it is similar, because in the octal number system there are 8 symbols, which is similar to the decimal, till starting from 0 till 7. In the hexadecimal number system, as the name implies, it contains 16 symbols. Oh, how we can go for the 16 symbols, as we have only 10 numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then what about the rest of 6 numbers? The rest 6 numbers or the rest 6 symbols can be used from the alphabets or the After the 9, we are considering 10 as A. In this table, you can see in the decimal it is 10, in the binary it is 1010, in the octal it is 12, and in hexadecimal it is represented by A. That's why it is also called, it is a alphanumeric number. It means it contains alphabets as well as the numeric digits. Okay. In the hexadecimal number system, 10 symbols are 0 to 9 and the rest of 6 symbols are A, B, C, D, E and F. The decimal 16 is equivalent to 1 4 times 0 in binary, 2 0 in octal and 1 0 in hexadecimal. We will convert these numbers as well. Now we have to convert these numbers from one number system to another number system. Why it is required? Because human beings are generally understanding the decimal number system, but the computer systems are understanding the binary number system. Some another microprocessor or microcontroller systems are understanding hexadecimal number or the octal number. So that's why the conversion is required. We can convert from one number system to another number system. First of all, we are converting any number into the decimal number system. Any number means it may be binary number system, it may be octal, hexadecimal or any other number. Suppose I want to introduce a new number system which contain 9 symbols only. So we can use 0 to 8, the 9 symbols, and if it has any applications or number of applications, it may be famous in future. Okay, the first conversion is any number system to decimal number system. What is the formula to convert any number system into the decimal number system? The concept is to multiply each digit with its base value, then add all the digits. The addition will be the decimal equivalent, or you can use the formula. It is not a difficult formula. You can see on the screen the r to the power 0. A0 is the 0th bit, or we can say ones place bit, which is multiplied by the r to the power 0. What is the meaning of r to the power 0? What is the r? R is the radix or the base value of the number. Which number? The radix or the base value of the number which I want to convert into the decimal. Suppose I want to convert from binary to decimal, then value of r is 2. Suppose if I want to convert an octal number system into decimal, then value of r is 8. If I want to convert hexadecimal into decimal, so the value of r is 60. It is not a difficult formula. We will simplify this in the next few slides. It is a quick example. 25 in decimal number system. In the subscript 10 represent the base value. Suppose somewhere 25 is written. What should I assume? By default, it is assumed that it is in decimal number system. But if there are some another number system, I have to represent the base value or the number system. That's why 25 subscript 10. It means 25 is in the decimal number system. Next, it is also equals to 110001 in binary number system. There is base is 2. It represents the number is in binary number system. 31 base 8 और subscript में जो 8 that is 8, it represents 31 is the symbol, 31 is the number in the octal number system, and 19 base 16, it represents the 19 in the hexadecimal number system. Suppose I want to convert in decimal number system 125. 125 is also in decimal. And you are supposing I'm joking. No, it's a fun. I want to convert from decimal to decimal. It is a different one. If they both are same, but I want to convert using that formula only. Okay, so that's why 125 in decimal is given. I want to convert into decimal. What is the formula? Formula is multiply each bit with its base value. It means the 5 you can see on screen, the 5 is multiplied with 10 to the power 0, or in the formula it is r to the power 0. Here r is considered as 10 because the number system is 10 to 10. So that's why r is 10. Okay. 5 into 10 to the power 0, that is 5. 2 into 10 to the power 1, that is 20. 1 into 10 to the power 2, that is 100. The addition of these numbers is 125. Obviously, we know the conversion of decimal to decimal, 125 to 125. It is equal. The first conversion, the exact conversion we want to convert, the last one was for fun, not for fun exactly. It is the formula which we have used to conversion, we want to prove it. Okay. The first conversion is binary to decimal number system. The concept is same, in which the base value is multiplied by each bit and the resultant will be in decimal number system. Multiply each bit with 2 to the power n, where n is the weight or the bit place, 2 to the power 0, 1, 2, 3 or up to n minus 1, and add to get the decimal number system. The example to conversion from binary number system to decimal number system. It is simple as the last example. The first or the unit digit, the one that is multiplied by 2 to the power 0, the resultant is 1, because 2 to the power 0 is 1 and 1 multiplied by 1 is again 1. 1 is multiplied by 2 to the power 1, that is 2. Again 0 is multiplied by 2 to the power 2, that is 0, because some number or anything multiplied by 0 is equivalent to 0. The next is 2 to the power 3 into 1, the next is 2 to the power 4 into 0, the next is 2 to the power 5 into 1. And now I want to add these numbers. The total is 43. The 43 is in decimal number. 43 in decimal or 101011 in binary. Both are equal. It is the conversion of binary number system to the decimal number system. I think you got it. The second one is from octal to decimal. Octal means we have 8 symbols. 8 symbols from 0 to 7. If I am saying 9 is the symbol, if I am saying that 9 is the symbol in octal number system, then it is completely wrong, because in octal number system there is no 9 as a symbol. There are only 8 symbols from 0 to 7 only. 0, 1, 2, 3, 4, 5, 6, 7. And the next number will be the combination of these 8 numbers only. Okay. The next conversion is octal to decimal. In the octal number system, each bit is multiplied by the 8 to the power n, or where n is the place value or the weight. It is the example conversion of the octal number into the decimal. Suppose the number is 724 in octal. Then the unit digit or the 4 is multiplied with, we know, r to the power 0. This time the r is the 8. So that's why 4 into 8 to the power 0. Then again 2 into 8 to the power 1. Then next is 7 into 8 to the power 2. The total is 468. 468. 468 is in decimal system. Okay. So now we can say 724 in octal is equivalent to 468 in decimal number system. The next conversion is hexadecimal to decimal number system. Hexadecimal, which contains 16 symbols. 16 symbols are 0 to 9, 10 symbol. After that A, B, C, D, E, F. The 6 symbols. The total is 16 symbols. Okay. The technique is the same as the previous one, like binary or octal to decimal. It is also same. Now we are going to multiply each bit with 16 to power 0, 1, 2, 3, 4 up to n minus 1. Suppose I have 5 bits or 3 bits in hexadecimal. I have to multiply 16 to power 0, 1 or 2. Okay. Let's solve the example. Yes, ABC in hexadecimal. It is a valid number in hexadecimal. If I am writing A, B, K, K is not a symbol in the hexadecimal. So that's why it is invalid in hexadecimal number system. Hexadecimal number system contains only 0 to 9 and A to F. Okay, suppose ABC is in hexadecimal, then convert into the decimal, or what is the equivalent to this in decimal. So the procedure is same. C is multiplied by 16 to the power 0, B is multiplied by 16 to the power 1, and A is multiplied by 16 to the power 2. A is considered as 10, B is considered as 11, C is 12, D is 13, E is 14, or F is the 15. So that's why I am just total. The total is 2748 in decimal number system. It means ABC in hexadecimal is equivalent to the 2748 in decimal number system. The first conversion was any number system to decimal number system. We have taken 3 categories or 3 examples, that are binary to decimal, octal to decimal, and hexadecimal to decimal number system conversion. We can use the same procedure for any number or the other number. Suppose I want to say base value is 5, I want to convert into decimal, so we can convert. We can use R as the 5, or if I am considering the 6 symbol number system, so we can use the R as the 6. Okay. Now the second conversion. The first conversion is from all number system to the binary, or all number system to the decimal number system. The next conversion is decimal to any another number system. Okay. The next conversion is decimal to any another number system. Let's first 50%.
तो उठ करके यहाँ पे एक रेड बटन है रिकॉर्ड का ना, वो दबा देना। लंच करने दबा देता हूँ ना, आप ऐसा होगा उठ करके, तो यहाँ पे हाँ बैठ रहो आप, तो यहाँ पे इस तरफ है, एक ही है बस, और कुछ नहीं है। उस तरफ एक रेड बटन है, उस पर लिखा है रिकॉर्ड स्टार्ट स्टॉप।
ठीक है,
उस बटन को दबा देना एक बार।
ये सामने वाली लाइट बंद हो जाएगी, सोनी वाली जो लिखी है।
हाँ, ये बंद हो जाएगी।
ठीक है।
और यहाँ पे स्टैंड बाय लिखा जाएगा स्क्रीन पे। अभी रिकॉर्डिंग चालू है ना। तो मैं ये लंच करके आता हूँ, इसको दबा देना और कुछ मत करना, ठीक है। और लैपटॉप को बंद मत करना, ऐसे रखना, ठीक है सर। यूज करना होगा, ठीक है। क्लोज मत करना, दोबारा करना पड़ेगा। ओके सर, शुरू करो आप।
The second conversion is decimal to another number systems. Another number systems are binary, octal, hexadecimal, or any other number system. Okay. First conversion is decimal into binary. To convert the decimal number into the binary number, we use the division method. Divide by the number and we are tracking of the remainders. Okay, we will see using the example. With the help of example, it will be very easy. No. Suppose 125 is in decimal. Initially, I converted the any number system into the decimal number system. I am doing the reverse now. Reverse is decimal to any number system. Suppose the first example is I want to convert 125, which is in decimal, into the binary. Okay. So the division method is 125 divided by 2 or divided by the any number in which I want to convert the decimal number. Okay. So that's why the value of base is again 2. 2 is divided 125 is divided by 2 62 times completely and one remainder. We should write remainder in parallel. Okay. Then next, again 62 is divided by 2. It is completely divisible 31 times and the remainder is 0. We should the remainders along we should write the remainders along with the numbers. Again, I am again dividing 31 by 2. It is completely divisible by 15 times. It is completely divisible 15 times and the remainder is 1. Again, I am dividing 15 by 2. It is completely divisible 7 times and remainder is 1. Again, I am dividing 7 by 2. It is completely divided 3 times and 1 is remainder, and I am again dividing 3 by 2. It is completely divisible by 1 time and the remainder is again 1. Okay. Now I am dividing 1 by 2. If I am dividing 1, only the remainder will be 1. Okay. Now it is the complete. Now, how should I write in right manner? I should write from down to upward like this. The arrow shows how can I write or how should I write. 1, 1, 1, 1, 1, 0, 1. Again, I am repeating. I should write from bottom to upward. It is only the remainders. 1, 1, 1, 1, 0, 1. Following the arrow. Okay. It is the correct binary representation of 125, which is available in decimal. Okay. I think it is clear to you all. The another conversion is decimal to octal number. Decimal number system to binary system we have seen. Now the second conversion is decimal to octal number system. Octal number system, as we already know, that it contains only 7 symbols or 8 symbols, not 7. It is 8 symbols, that is 0 to 7. Okay. Again, dividing like a binary, like base 2. The technique is the same and keep track of reminders. Suppose 1, 2, 3, 4, it is in decimal. I have to convert this into octal number system. Then I should divide by the 8. 1, 2, 3, 4 should be divided by 8. It is divided 154 times completely, and 2 is the remainder. Next, if 154 is again divided by 8, it is completely divided by 19. So it is completely divisible 19 times, and 2 is again remainder. Again 19 is divided by 8. It is completely divided by 2 times, and remainder is 3. Again 2 is not greater than 8. So that's why the completely divisible by 0 times, and the remainder is the same as 2. Okay. Now what should be the right manner to take the octal equivalent or the in octal number system? Okay, we should write from bottom to upward. The bottom bit is the MSB bit. MSB means most significant bit, and the upper one is the LSB bit. LSB is the least significant bit. Okay, so 1, 2, 3, 4 in decimal number system is equivalent to 2, 3, 2, 2 in the octal number system. Okay. Yes, it is the exercise. Some numbers are given in the decimal, binary, octal, and hexadecimal. You can convert these numbers into binary, octal, hexadecimal, or another number system. Okay, you students, you should not use the calculator to convert these numbers or the conversion of number system, and it is the right answer table. You can verify your answers with this table. Okay, thank you. I hope you will understand the conversion of number system. In the next class we will discuss them. Thank you.